Hello everyone, and thank you for tuning into my presentation. My name is Hayden, and I'm with the Human-Centered Robotics Lab. I'm a 5th year computer science student, and I'm a MRF student with Dr. Zhang. This is my poster that shows the research that I've been doing so far this semester. I'll delve into it piece by piece in this presentation to showcase my work that my lab and I have done. The field of multi-robot systems is currently undergoing a massive spike in popularity. There's an increasing emphasis on heterogeneous aerial and ground multi-robot systems due to their versatility and effectiveness in multiple different scenarios. These scenarios include surveillance, search and rescue, military, assembly, and countless others. However, there is not yet a standard way of testing these systems and algorithms. Often, when one wants to test a new algorithm for their multi-robot systems, they have to create and assemble their own robots and tracking systems. This takes up a large amount of the researcher's valuable time and money. Another issue is that since all of these testbeds are different, it is difficult to directly compare the effectiveness of different algorithms. If one team uses a more capable robot than another's, it may appear that their solution is better, even if their algorithm is less effective. This project provides a proposal for a standardized testbed that can evaluate these, called MATS, which is a multi-robot algorithm testing system. It consists of 3 parts: the ground robots, the aerial robots, and the motion capture system. These elements are kept agnostic so that the algorithms of most multi-robot tasks can be tested within the system with very little to no change to the hardware or software. It's easy to set up, cost-effective, and generalizes to many different multi-robot scenarios. The ground robots that are used in this testbed are the Triton robots, created by the Colorado School of Mines' own HCR lab. A Raspberry Pi operates the networking, ROS commands, and high-level controls, while an Arduino operates the low-level controls, including the PID controllers and motor commands. The Tritons receive drive commands from a central computer over the LAN and perform their movements in sync. The movements of these robots are abstracted so that a single ROS command is efficient enough to fully operate them. This means it is simple to adapt existing algorithms to be tested in this environment. These Tritons have a flat, circular top that is illuminated by ring light that can serve as a landing pad for the Crazyflies. The aerial robots that are used in this testbed are the Crazyfly 2.1 robots, created by the company BitCraze. The Crazyflies are also controlled by ROS commands over the network. In the MATS system, they run software by USC called Crazy Swarm, which allows for the Crazyflies to operate together in a swarm fashion. This allows the central computer to control the swarm as a whole, while the individual controls of the Crazyflies are abstracted away. However, they can still be given commands individually if desired. These factors make it easy for new algorithms to be tested in MATS with virtually no adaptation for the system. The tracking system is created by the company OptiTrack. There are 8 of their cameras arranged on beams that surround the testbed, which all point towards the center. These cameras are able to track the location of the ground and aerial robots with high precision and report their 3-dimensional positions to the central computer. This makes it easy to examine the movements of the robots and test the effectiveness of numerous multi-robot systems. MATS has proven to be a successful testbed for the purposes of heterogeneous multi-robot systems. The Human-Centered Robotics Lab at the School of Mines has used MATS on multiple occasions to test the effectiveness of algorithms designed for multi-robot systems. MATS was used in the successful dissertation of the PhD defense of Brian Riley to demonstrate representation learning for human-robot teaming with multi-robot systems. MATS provides a common testing point for multi-robot algorithms. It saves time for researchers who may have to build the robots and tracking systems all on their own, and it's a cost-effective solution that can generalize to multiple different scenarios. The hope of this project is that moving forward, researchers who desire to test their multi-robot algorithms can use MATS, and there will be stronger standards in this field. Here's a list of my references, and I want to say thank you for listening to my video. I'd be happy to take any questions either on the online discussion board or emailed to me directly at hrsather@mymail.mines.edu. Thank you so much for listening. Hope you have a great day.